Hello, welcome back. I'm Luke Perkin, and this is Advent of Code 2021, Day 9. So let's have a look at what is in store for Day 9. Smoke Basin. The caves seem to be lava tubes. Lava tubes, eh? What are lava tubes? A lava tube is a natural conduit formed by flowing lava from a volcanic vent that moves beneath the hardened surface of a lava flow. If the lava in the tube empties, it will leave a cave. That's cool. So, the caves seem to be lava tubes. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the caves for you. That's going to be our puzzle input. Smoke flows to the lowest point of the area it's in. For example, consider the following height map. It gives us an example here. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest a location can be. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations, up, down, left and right. Locations on the edge or corner of the map have 3 or 2 adjacent locations respectively. Of course, yes, so it doesn't do like wrap around. In the example above, there are 4 low points, all highlighted. 2 are in the first row, a 1 and a 0. 1 is in the third row, a 5, and 1 is in the bottom row, also a 5. All other locations in the height map have some... All other locations on the height map have some lower adjacent location and so not low points. Okay, so we've got to figure out the low points of each of these. That's pretty simple enough. We've worked with sort of 2D maps before, I think, when we had to like draw lines and see where the lines overlap. So we can reuse some of that logic, and we're just needing to read adjacent pairs. The risk level of a low point is 1 plus its height. In the above example, the risk levels of the low points are 2, 1, 6 and 6. Therefore, the sum of the risk levels of all low points in the height map is therefore 15. So I have a 2 plus 1 plus 6 plus 6 equals 15. And there, the low points in the map were 0, 1, 5, 5, but it's 1 higher than that. Got it. Okay, so here's our day. Let me come to this view. Here we go. I made one slight tweak since my last video. In my main file, main.c, I've created this function and macro to run a day and actually spit out how long it takes to run each function. So if you can see here, calculating day 1 took 5.8 milliseconds. And then at the very end of the time, at the moment we're running 8 days, and in total it takes about 41 milliseconds. Although if I was to run that again, you know, see, it takes 9 milliseconds. So now it's taking, I thought it took a long time initially. So yeah, running all 8 days takes about 9 milliseconds. If we wanted it to be really fast, I can go to our build vs.bat, and you see here it is dash big OD. That means we're sort of building in debug mode. If I did O2, it's basically disabling optimizations. O2 tells the compiler to go ahead and sort of look at all the code and figure out ways to compile it better for the processor. So if I now run this and run it, you can see it's now about 5.9 milliseconds, which is 4.8. Yeah, around 5 milliseconds to run it. I think my stretch goal for Advent of Code, it would be cool if we could get all 25 days running in less than a frame if it was in a video game, so 60 frames a second. If we can get Advent of Code to run 60 times a second, that'd be pretty cool. That's more of a stretch goal. Okay, so let's go ahead and create our day 9. And here we go, day 9. And let's go ahead and create our input day 9 dot text. There's our input. And then in our main, we're just going to include day 9.c. And then down here in our main function, I'm going to do our timer plus equals run day 9. And then we need to make our void day 9 function. This is what gets called by the macro. Compile that, and that oops, I said include, and that's compiling. So let's come back to our example here. So it's giving us some example input here. Let's go ahead and put that into our input. So it's a series of digits followed by new lines. So what we can do now is do our include our input helper. And let's do bool day 9 read input, and if you remember, was it we get the file and we get, I always forget, our input helper. We get a file, we get the count and the user data. So use 64 count and avoid user data. So our user data is just going to be a list of bytes, U8. So we'll call this our values, which is just going to be user data. And then what we're going to do is the good old scanf. And then to do this, I'm going to use what's called a character set. So if I put this in brackets, I can do like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the new line character. So that's going to be our char C, and we're going to pass it in that. That's going to be our int scan count. If scan count does not equal 0, we're going to do because we also want to figure out the width. Let me come back to here, get our puzzle input. The width between our example and our actual input is different, but I think there's a way we can work this out, and I'm just going to say static I32 day 9 grid width to begin with is -1, and we can say, right, if C is equal to new line and our day 9 grid width is equal to -1, then we can set it. And we can say our day 9 grid width is actually equal to the current count value. Otherwise, C is not equal to a new line, then we're going to do U8 digit equals A to I C. And then I'm going to say our values count equals digit. And we're going to return true, otherwise we'll return false. And then we're going to say read puzzle input, that's going to be our input, day 9. We're going to pass in our count and our grid. And so our U64 count starts off with 0. Our grid of U8, I'm going to use malloc for this. Day 9 max input count times this. Let's define it to be, I don't know, 9. Right. And this becomes did read. And then if did read, I'm just going to printf day 9 count equals percentage I64u, because it's a 64-bit number, and we're just going to give it count. See if that compiles. All right. Oh yeah, we need to pass in f. So A to I expects a char star, but we can basically do 0. We can do C minus 0. Make sure that's a U8. Read puzzle inputs, too few arguments for call. Oh yeah, we need our function. Let me put these on new lines now. So this will be day 9 read input. So let's run it. Day 9 count equals 0, which is obviously wrong. Let's look at our input again. Let's printf percentage that new line. I want to see what C is. So our character set, he usually lets you put in a character set. Any number of the characters specified between the brackets. Oh, does it have to, do I need to put a percentage in front? So it's reading the 2. I want to see scan count. I want to see my input helper. So we're calling handle line in our loop. We could just do character here. And this will be each of these, but here I want to return false. And printf unknown character in day 9 input. I guess because it would get the end of file character or space. Let's see. I want to print out the digit. So it is printing out the digits now. Input day 9. It gets to what? 10398 949 21, but then it gets to this unknown character in day 9 input. Should be a I'm gonna do this if then we set that. So we always return true. There we go. Day 9 count 55. So that looks good to me. So if I wanted to print this back out now, I could just do for y equals 0, y is less than I could also do static I32 day 9 grid height equals 0. I'm going to set these to 0 by default. And we're going to increment the height on each new line. So then I can say it's less than day 9 grid height y plus plus. X is less than day 9 grid width x plus plus. Then I just becomes x plus y times day 9 grid height. Feels weird saying day 9 a lot because it's one of the Twitch streamers I sometimes watch. And then our digit just becomes our grid I, and then we can printf %u will print the digit, and each new line will printf a new line. Right. So if I run that, oh, what's wrong? What's wrong? I just want to check if I is less than count, then we print this. Otherwise, error I too large. What's going wrong here now? We also need to free our grid That's not going to be an issue so far. Seems to be here. What's causing the error? Let's have a look then. So y equals 0, y less than day 9 grid height. Let's print f percentage d. I want to see the grid width and grid height. And for now, let's just comment you out. Interesting. Why are we getting this now? Let's get the good old remedy in the go. So it seems to be, if we go to day 9, let's restart. Make sure I've disabled optimizations again. So let's go back to day 9, let's compile this, and let's start debugging. Okay, and let's step over. Step over. So if we watch C equals 2, so that's working just fine. C now equals 1. So it's done that just fine. Let's have a look at our grid. Unable to read process memory. Why? For whatever reason, it doesn't like our grid. Malloc. This should really be. You know. What's wrong with grid? Malloc. Try it with calloc. Should be the exact same thing. At grid. As our user data. confused. Oh, is it because I'm passing in... Ah. I always make that mistake. I don't need to pass in a pointer to grid because it's already... Alright, that can be malloc again. No point making it calloc. There we go. So it's saying its width is 10 and its height is 4. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then its height is 1, 2, 3, 4. But obviously we're not getting the last new line. So our grid height technically needs to start at 1. And if we run that, we now get 10.5. Okay, let's make sure I'm freeing the grid now. Get rid of you, get rid of you. Right. Compile that, run it, and there we go. We're getting our 1, 2, 3, 4, 5 lines. Are they identical? No, they are not. The first line is correct. I am... But then it deviates at the second line. I wonder why it does that. Wait. Yeah. Where's my 98999? We're reading it character by character. Oh, because our count... We don't want the count to increase in either of these cases. So we actually want to do count minus minus here and here. Oh well, just here, because we return true. Again, I should have really left incrementing the count to be inside our day 9 read input. And in fact, I'm going to do that now, might as well. So if I go to our input helper, basically I'm going to get rid of you. And then this just becomes, if not handle line, we break. And then this can go. And then this can basically become this, right? But I'll do it here instead. That does now mean we have to now go back through all the previous days and make sure that still works. But if I compile this, yeah, we're getting a lot of so let's go to 8. Where's the line where we read our input? Just need to do count plus equals 1. Let's go back to day 7, where we read our input. We're using scan integer comma list. So This becomes that. This becomes that. Oh, I see now. I forgot the. There we go. So that was day. Now we go to day 6. That was using that, so we don't need to do that. Day 5, where we use read puzzle input. That was using scan vector 2D pair. So we need to change this to like a scan count. Does not equal 0, then I'm going to say our count plus equals 1. We return true, otherwise we return false. Let's go to, what was that, day 5, so now day 4. Read day 4 input. We're still using the old method here in day 4, so we don't need to do anything with that. Let's go to day 3. Again, I think we're still using like the old way of reading, so we don't need to do anything with that. Day 2, read day 2 input. Same situation here, and day 1. We're doing scan integer white space list, which is just using this. So let's compile, let's run it. We might have broken all our previous days, but oh well. After 256 days, there are 0 fishes. Like day 6 looks booked, but I'll come back to that another time. And for now, we've got an issue with day 9, error I too large. So let's go back to 9. So here we increase our count by +1. And this is obviously going on way too much. Why is that? Let's go back to our day 9 input. Get rid of this. Oh, yeah, we need to. There we go. So our day 9 count equals 51. It should really be 50. I guess 51 kind of makes sense, does it? No, it doesn't make sense. But at least it is printing out, what, 985. In fact, no, it's still wrong. Where's this 4321 coming from? 43210 here. I have a feeling I x plus y times day 9 grid height. So grid so I want to see what I is. Just a second, let's comment all you out. Let's print, so if this is 10 long, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 should be 3. Oh, I forgot to put in a new line. Yeah, 11 should be 9. But it's saying 11 is 3. Oh, sorry. I'm just going to say I equals 0 plus 10. Plus 1 times 10, right? I'll say that's U16, right? So that's 3. If I now change x to 1, I should get grid 11 equals 9. Okay, so if I change, so this is y0, y1, y2, y3. So if I change u to 3, I should get 7. And that's working. So basically this sort of so our width is 10, our height is 5, that's correct. So how come this wasn't working? We were going yx, x plus y times O. That's why that wasn't working. It needs to be y times width. And then we printf percentage u digit. And then this can go. Now I'll compile that, run it, and if we compare these, they are at a glance the same. Okay. Okay, so we've read our input. Now we just need to do the thing where we look at the adjacent cells. Let's have a look at that. So we just need to, for each digit, look at the one above it, to the right, below it, to the left, and if it's the lowest value of those 4, we add that to our low points list. So let's do that. So we're going to have our U64 low points count, which is going to be equal to 0. In fact, no, we can just sort of have a tally of our risk level. Our risk level equals 0. This is day 9. Width height. Put me there. So we're going to go through each of our, so this is going to be our cell index. Cell index is less than our count. We then need to look at, so this is looping through, we then need to look at sort of north, east, south and west. So the easiest would be east. So east is just x plus 1. So I could say like east digit is equal to grid cell I plus 1, right? But we don't want to check the east digit if basically if our x is equal to day9 grid width minus 1. So we only check it if actually it's less than this. Next would be U8, our west digit is just equal to our grid cell I minus 1. But again, we only check that if our x is greater than 0. Let's look at our south digit. So that's our grid. So that basically becomes our current x plus our y plus 1, right? Times day9 grid width. So we'll probably be using this in multiple locations, so let's make that a let's do one dim code from 2dim. One dimension coordinate from a 2-dimension coordinate, so that would have our int 32, our I 32 x and our I 32 y. This is specifically for day 9, so I'm going to say day 9 1D from 2D, and that's just going to return x plus y times day 9 grid width. So this becomes, oops. U8 north digit becomes our grid day 9 1D from 2D x y minus 1. And in actual fact, what I could do is put these all as cells. So our U8 north cell is this. Our east cell is equal to this. The south cell is equal to this, and our west cell is equal to this. And then we could just set this to like our east cell I, west cell I, So if y is less than day 9 grid height -1, and if y is greater than 0. And then these digits by default, and we're just going to say UA east digit, west digit, north digit, and south digit equals 0. So we define them up front. And then we're basically checking if our digit is less than our south digit and our digit is less than our, well, let's go around the plot properly. So north, south, oh sorry, north, east, south, west. So if it's less than each of these, then we found a low point. So basically our risk level, we increment it by our digit plus 1. And then I'm just going to say found low point digit. Let's cut you out, put you there. Okay. That compiled. Let's run it. Found low point 1, found low point 5. Is that right? There are 4 low points, 2 in the first row, 1 in the 0, and then we've got 2 5s. Right, so obviously because we're sort of implying that our grid is surrounded by zeros, what we actually want to do is imply that our grid is surrounded by really high values. And get rid of this print new line. I also want to do that in here. So there we go. We found low point 1, 5, and 5. So it's found 3 low points, but we know we want to find 4. Also, this should never be that case, but whatever. There are 4 low points. So why is it not finding the 0 low point? Let's look at our east, west, south, and north. East and west. North, y minus 1. Y plus 1. So here's what I'm going to do. I'm going to say if it's equal to 9, 0, I'm just gonna printf cell 9. And the reason I'm doing this is so I can come to our remedy bg and set a breakpoint for that cell. So I just want to see what logic is running when we get to this 0. So I'm going to run it. So here we are. If we look at our grid, we can see grid 9 is equal to 0. If we look at our x and our y, or if we look at our x and our y, that should be 9, 0. So let's step over. So let's look at our digit, that should be 0. Let's look at our west cell, or rather grid west cell I is 1. If we come back to this, you can see that's correct, it's 1. So let's do this. So it looks like, yeah, it skipped over the east digit. It's doing the west digit. So what's our west digit? That should still be 1. It's doing the south digit. What's that? That one should also be 1. Correct. You should skip over the north digit, so that should still be 255 or 251. Why? Oh, is that because these need to be like... I'm just going to set these separately. Stop that, compile it, run it. So it has found the low point 0. Oh, there we go. It's found 4 low points. I think I just, the way I was doing that. Cool. So this can go. Printf day 9 risk level is I think I set risk level as a U64. Let's compile it. It has to be capitalized, doesn't it? Run it. Risk level is 15. The sum of the risk levels is 15. Got it. So let's get our puzzle input. Paste U and run. So it's found a bunch of low points. And it says the risk level is 2085. That's not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. So is that because our width is 100 by 100, our count should be 10,000, and our input count is too small. Let's just double that. But it's still saying 2085. So something is wrong. Let's have a look. I'm going to say found low point at, and then I'm going to do the percentage U, and we are using U8s for our width and height, which is fine because our width and height never goes more than 100 either way. So we've got no overflow issues there. So yeah, I want to see at, but we are using U8s for our indices, which isn't the correct yeah, so these really should be probably U16s. Or I mean, I do return them as I32s, so I'm just going to keep it in the same format that the function returns. Let's run it. Risk level is 496. And that's the right answer. Cool, we can go on to part 2. Let me finish my tea. Next, you need to find the largest basins so you know what areas are important to avoid. A basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin. Although some basins are very small, locations of height 9 do not count as being in any basin, and all other locations will always be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. The example above has 4 basins. The top left basin, I see, so the 9 sort of create walls. The top right basin, which is size 9, the middle basin, so we kind of need to do basically a flood fill of the grid from each low point until we hit a 9. Find the 3 largest basins and multiply their sizes together. In the above example, this is 9 times 14 times 9. So we need to get all our basins, keep track of the 3 largest ones. Okay. I think that's doable. You can see, yeah. So let's see how we can do this. So we need to do a sort of a flood fill from each of the low points. So here's what I'm going to do. I'm going to create a new array of low points. and then I use 64 load point count, and then I need to remember to create our low points, and then if it is, what I'm going to do is I'm just going to append it, so it's going to equal to cell I. This can now go. So once we found our low points, we need to do a flood fill. So essentially we're going to go for low point I equals 0 while low point I is less than low point count, low point I plus plus, and then we're going to get our I32, which is our cell I, which is going to be our low points, low point I, and then we're going to do kind of a find, or a D9 find basin, and we're going to pass in our grid and our cell I, which is our low point. Grid, this is actually our sort of height map, right? Not grid. So there's our height map. This becomes our height map. Or height map count. Just copy height map again. Alright, let's see if that compiles. Count is undeclared identifier, so that becomes our height map count. So we need to create our void find basin. That's going to take in our U8 height map and our cell I. And then, so how's this going to work? We're going to have an open list. Sorry, why have I done 64? I'm 32. I'm not going to mark this because it's going to be fairly small. Our open list will never be more than say 999. And then basically we're going to say, and then we'll have a and then we're going to say our open list count equals our first cell, and then we're going to have a loop that says while our open list count is greater than 0. This could probably be a U32, not an I32. We're going to do our flood fill. So let's write this how I would expect to do. So I would get our cell, well, first of all I would say if our height map cell I is equal to 9, then we would just return. We'll do an early return. Otherwise, we add it to our list, and then here's what we're going to do. We sort of want to do we want to get the north cell, and that's going to sort of be get adjacent cell from our height map cell. So our current cell I'm going to say our starting cell I is going to be equal to our open list count minus 1, and then our open list count will decrement. So I think that makes it a depth first search. So we're going to pop the first cell of our open list. Then I want to get an adjacent cell, and I kind of just want to be able to say with this height map, this height, and sort of do, I want to get our north cell. And actually, I want to do this as I32 northeast southwest at north. So this becomes an if statement. If get adjacent cell north, then our open list count equals north. And if our height map cells north does not equal 9, then we add it. So our height map now becomes a structure, right? So our struct height map, or rather it's a cave, I call it cave height map, is going to have cells. It's going to have an I32 width and a height. And so our user data actually just becomes our cave height map. And this becomes U64 count. So then we say our struct cave height map. I'll call this height map cells. Our height map cells equals our height map cells. This can go. Our height map dot count should equal 0. Our height map dot width should equal 0, and our height map dot height should equal 1 by default. So we're going to pass in our height map dot count, and now we do pass in an address to our height map structure. So then this becomes height map width. That does now mean we now need to pass in our struct cave height map. I'm just going to call that there. Oh. Or HM. That becomes our HM.height. Well, because it's quite a big structure. Sorry, not our height, our width. So same here, our struct cave height map. So now we have our enum. And then we've got our get adjacent cell, which returns a true or false value. Takes in our cave height map. I'm just going to call that HM for now. Takes in our cell index. It takes in our enum cell direction. Call that dir. And it takes in a pointer to our out cell I. So it becomes this. So get adjacent cell. Basically we copy this. Where we say if our HM width we basically do a switch dir. We can do case north cell. We can say we sort of want to do the inverse operation here, which is I32 day 9 2D from 1D and it actually returns a... There was a day we were using vectors, wasn't there? A vector 2D. So what I'm actually going to do is create a new file called common. And move this to common. And actually these can be common functions as well. I'll call this vec. And this actually just becomes our I32 width. And this becomes our, I guess we need both width and height in here. So to construct our cell I, again, that's just vector 2D v.x equals, and this should really be I32. Figure out now, you divide, it's just cell I modulo the width, right? And then v.y is equal to cell I divided by the height, and this returns a struct vector 2D, and this will automatically floor it as well, or truncate it. So then we would do our struct vector 2D chord is equal to vec 2D from 1D, and you pass it in the HM width, HM height, and our cell I. And so we're saying if our chord dot y is greater than 0, then we can say our out cell I is equal to, what's our north? We'll just get these as well. Is equal to vec 1D from 2D. We pass in HM width. Chord.x, chord.y minus 1. Return true. Let's do south cell. east cell. So again, if our core.x is less than our HM width -1, then our out cell I is equals vec1d from 2d HM width core.x plus 1 core.y return true. Break on our case west cell core.x is greater than 0. Out cell I is equal to core.x -1 core.y. Turn true and break. So we can get rid of all this. Get rid of these. And then I can like say our outside equals 255 by default. And actually, what we could do is change this to a vector, right? So I could say struct vector2d size. There you go. And then this would just take in a struct vec2d size. And then instead of saying width, we say size.x and size.y. This still only needs to take width. But if we wanted parity, I could, then that just becomes size.x. So now this just becomes our size.x. There we go. Okay, so finding our basin, again, so we reconstruct our open list, we add our starting cell to the open list. While we have items in our open list, we pop one off the top, and then we're going to do get adjacent cell. Height map cell, north cell, and then we're going to say, well, if that north index, if we do get an index back and it's not 9, we open to the list, and we basically need to do this 4 times. But we don't need to do it 4 times like this. We could just put it in a loop, because we know this is equal to 0, this is equal to 1, 2, and 3. And then I can put cell.count count here at the bottom. This will be equal to 4. Let's just compile. We still have a few things, so this becomes hm size.y, size.x. This becomes cell I. This becomes our height map.count. This becomes height map cells. Cells. I mean, all this is going to get this becomes height map dot size dot x. This becomes a pointer to height map. Free height map cells. Get adjacent cell. So cell I32 at I32. So this needs to be a pointer. Need to dereference those there. Unresolved external symbol, yep, because I've moved them, and we need to make sure we include our common.h. Where are they? So these just become back. And we need to pass in our height map size. Okay, compiled. So let's have a look at our fine basin. So we get. So then we need to wrap this into actually this becomes our adjacent cell with our cell dir count, and then for, let's say I equals 0, I is less than cell dir count I plus plus. Then this just becomes I. We're going to cast it to a enum cell direction, and this becomes a pointer to adjacent cell I. That makes sense. I don't think you need to do it like that. So then our height map cells, and then our I32 adjacent cell I is going to be equal to our adjacent cell I, which I know is kind of confusing, because this gets the adjacent, should be really get adjacent cell index. So if it's not equal to 9, we then add adjacent cell I to our open list. So we probably also want a closed list. Dismiss that. So when we take it off the open list, first of all, we're going to check if that cell exists within the closed list. So again, we're going to do for I closed list I is equal to 0, while our closed list I is less than our closed list count. Closed list I plus plus. So this is going to go check if current cell is in the closed list and ignore if so. So and basically what we're going to do is say if our closed list is equal to our cell I, we're going to break, and we also need like a bool here, like bool already checked equals false, but I'm going to set already checked equals true here, and if we have already checked it, we're going to continue the while loop. Otherwise, our closed list count is going to equal to cell I. Otherwise, add to closed list, and then add all adjacent cells to open list. Add all non-9 adjacent cells to open list. So this is sort of our flood fill algorithm. And then by the end of this, our closed list will create our basin. So actually that makes more sense. I'm going to call this the basin list. So that's going to be basin list I. So our basin list I, right, and then this is going to return the size of the basin list. So it's just going to return the basin list count. And then I32 day 9 find low points. Again, I'm going to give it our cave height map. And we're going to give it our low points, which was I32. And then what I'm going to do is copy you, or rather copy you, right, cut you, and then do day 9 find low points give it our height map and our low points. And then this goes into there. And we can refactor this as well. So we now know that this is actually our height map dot size.y, our height map size.x. These become pointers. And in actual fact, because we've got these now, what I can do is just say what was it called? Get adjacent cell index. I can do adjacent digits, cell dir count. We give it our height map. Cell I. North, and then a pointer to adjacent digits like 0. And I can sort of do for U8 dir I equals 0, dir I is less than . There we go. So all of this can go. This can go. This is actually adjacent cells. So UA north digit is equal to height map cells, adjacent cells, north cell. I just need to copy this 4 times, so this becomes sorry, east, south, and west. East, south, west. So we've got north digit, east digit, south digit, west digit. And then our low points, low point count. This needs to be a pointer again. So and then this can just be void. So it doesn't actually return anything. This becomes low point count. Actually, yeah, it returns our low point count. Okay, and so now we come down to our day9 function. We read our puzzle input. If we did read, we construct our low points. Our low point count basically becomes U. And then we can easily do our risk level by sort of creating a loop here where we go through each of the low points. I32 cell I equals low points, low point I, and then our risk level plus equals our height map cells cell I plus 1. So if I just do that for now, coming out part 2, so part 1 should still work. Day 9 find basin. Find basin, it should return, yeah, we'll just return 0. This basin list count is here. Okay, let's compile you. So that's compiling. If I run you, day 9, risk level is 496. That was correct, right? Yeah, 496. So that's still working. So coming back to part 2, we're doing the same thing here where we're looping over all of our low points, and then we're going to say find a basin. So I'm going to say basin count, or rather basin size, and then I'm going to printf day 9 found a basin of size, and then percentage D. Let's go to our input, delete it, let's go back to our example and run it. AOC has stopped working. Okay. So let's come to our remedy VG, get rid of you. Let's have a look here and run it. So we step over this. You could see also the output of you, but it doesn't seem to show that. So let's step over. So if we look at our cell I, it's looking at digit 1. Oh, it does print it here. Oops. Risk level is 190. Width equals 0, height equals 1. That's not right. Oh. Let me also get rid of these. So when we're doing that thing where we're printing here, that just becomes height map size.x and height map size.y. Right. So if I run you, so width 10, height 5, count 51, risk level is 190. For our example code, which actually doesn't sound right at all, does it? It should be 15. So let's run this. What's our risk level currently? Is 0. Let's look at our low points and our low point count 26. Okay, obviously that's not working. Why is low point returning 26? Let's run this. Let's look at our height map. Okay. Let's step over. So our adjacent cells is saying 255, 110, and 255. Ah. I think I know the problem there, at least. Because we were saying this returns, yeah, so we shouldn't really do that 255 here, that makes no sense. What we wanted to do is say, instead of saying get adjacent cells, get adjacent digits. This is adjacent digits, and if this returns false, I'm going to set adjacent digits to I equals 255. And then this can just be adjacent digits north. Makes it a bit cleaner as well. North, east, south, and west. So I'll compile this, run it. So we're still getting an issue there, but at least if I run this, I should see our count is 51, continue. Well, now it's saying our low point count is 45, which is not correct, is it? What's our risk level? 337. Okay, obviously something's still going wrong. What I want is to come here and run it. And I want to see adjacent digits. Of course, I now need to, yeah, my bad again. So I'm actually going to say else do that. Otherwise, it's actually equal to our height map cells adjacent digits to I. Does that work? I'm just gonna have an adjacent cell I, and this actually does I think that works a little bit better. So let me just run that here. Run adjacent digits 255, 13, 255. So we go over Continue 255992. And that adds it to the low points. So by the time we get to here, we print that. Saying risk level is 190 and a low point count is 26, which still seems wrong to me. Let me just do this again. Step into this. So it's looking at the north cell. And what's our coordinate? 0, 0. So it's going to break, turn false. Obviously it's then going to come down to here. So our adjacent digits for dir, whatever that is, currently 0. And then I'm going to step into here. Now it's checking the east cell. Our core.x is less than hm size.x, that should be true. So it's going to get vec 1d from 2d, core.x plus 1, core.y. So our out cell I set, return true. And then if we look at our adjacent cell I, that's now equal to 1, which is 1 east. So it's going to get the value from there and put that into adjacent digits. And then it's going to look again, it's going to look to the south, that again should work. And now it's going to get the current digit, which is what? 2. Is 2 less than 25513 and 255? No. So it's currently looking at this. But the next one should work. So it's going to skip over that. So if I loop over these, we should get 9, 9, and 2. Our current digit is 1, so it's going to add that to our low points. So let's press play, play, right, play. So we got 255981. And our digit is 9, so it should not go in the low point. Continue. 255979, and our digit is 9, so it doesn't go in our low points. So I want to see when it becomes a low point. I can do that by doing cell I. Saying the digit is 4 and cell I is 16. So if that's 10, 9, 10, 11, 12, 13, 14, 15, so it's looking at this 4. But look, there should be a 3. But it's saying 9759. Where's that 7 coming from? What I want to know. Where did that 7 come from? Because the adjacent digits should be 9, 9, 9, and 3. So let's have a look. If so, it's happening when we get to what was that? 10, 11, 12, 13, 14, 15, 16. It was happening when we got to 16. Just gonna print that there, and then I can come and breakpoint here and press play. All right, cell I equals 16. I'm going to step over. So it's currently checking north because I'm going north, east, south, west, and it's adding to north What's it doing? I should be here. Has it done? Okay, now it's doing it. Wait, why is it saying Celi is I want Celi to equal 16. There we go. I think part of the problem is, let me just compile this again. Run it. There we go, okay. Celi 16, let's step over. Let's step into get adjacent cell. So it should be looking at the north. Our coord is 6 and 3, so it's going to return true. And our adjacent Celi is now saying 26. Which doesn't seem right to me. The north cell should be, if that's 9, 8, 7, it should just be 6. So I think we have a problem with our code where we're doing get adjacent cell index vec1d, possibly or vec2d from 1d is wrong, and it might be this. So let's consider this code again. If our width is 10 and our height is 5, then the first digit on the second row should be index 10. So if we do 10 divided, and this say oh, do we also need to divide it by x instead of y? I think so, because then it would be 10 divided by 10. If we were to do if this was 15, it would be let's have a look, 15 divided by 10, which is equal to 1. So if you have it on programmer mode, I think it, so 20 divided by 10 equals 2. Yeah. So I think that was the problem. It needs to be xx here, which does mean we never actually use size.y. We could change that here, but I'm not going to for now. Let's compile it. Oh yeah, because this is still using it. Let me just stop you. Compile it. And let's just make sure we set our breakpoint to here. Press play. Let's see what it says. Risk level is 15. And if we continue, it says the program halted. So that means I can come get rid of this. Don't need that anymore. If I run it, oh, there we go. Found basin of size 3, 9, 14, and 9. And if we come to example 3, 9, 14, and 9, we need to find the 3 largest basins. So we can do that by sort of having our I32 basin sizes, let's do that here. So we this becomes our basins. And our basin count. And then we're going to add to our basins basin count equals basin size, and then we're going to sort our basins. So if you remember, I think in day 7 we did Q sort. So that Q sort ascending can go into our common. So let's go to day 9. Make sure we include our math.h. So we're going to do our basins, our basin count, size of I32, Q sort ascending. And then it basically just becomes the top 3. So if I cut you out, I equals basin count minus 3. Basin count I plus plus basins I. So that should now print the top 3, 9, 9, and 14. Obviously this kind of needs to be max that, and I don't want it to go below 0. And then what was it? Multiplied together the sizes of the 3 largest basins. So we'll do our U64. We'll just call this our result. Starts off as 1. and then it'll be results times equals basins I. There we go. Found basin of size I, and then we'll do printf day 9 basin results equals percentage I 64U. Let's run it. So basin result, if you can see that, 1134. So that's for our example code. So let's now do our actual. So that's in our day 9. Paste, save, and run it. And if we come down, day 9, basin result is 902880. And it took 2.4 milliseconds for us to compute that one. So it is one of the more slower ones. I think so far our day with the slowest algorithm is day 5, taking 4.5. So day 9 is currently our second slowest. But let's see if that is the result. That is the right answer. And there we go, we've completed day 9. So yeah, today was definitely better than day 8. And I'm interested to see what day 10 has in offer. Thank you very much for watching.